So the atomic mass of each element is given on the periodic table, and that's the number below the element symbol. Now if you look at those numbers, those are not nice whole numbers, are they? They're messy numbers with varying decimal places behind. Yeah, it's like nitrogen is 14.0067. And we can't just round that to 14 because we'd like to. Those atomic masses, the mass of an average atom, are averages. That sentence didn't turn out very well at all. How do we get an average? Well, normally with a reasonable number of things, you add the values together and you divide by the total number of values, right? That's great if you're dealing with 10 or 15 or even 100 things. If you're dealing with 65 gazillion things, there's actually not time in anyone's lifetime to do that, so you can't do that. So we use what's called a weighted average. So the percent natural abundance of each element, each isotope, is known. It'll either be given to you in a problem or you can look it up in your textbook. Generally, it's just handed to you in the problem. So here we're given that naturally occurring chlorine consists of 75.77% chlorine 35 and 24.23% chlorine 37. So to find the average mass, instead of adding up a whole bunch of numbers, we can use the percentages and do a weighted average. So we take this 75.77%, and that's 0.7577. We multiply that by the mass of that isotope. These numbers would have to be given to you as well. This is 34.97 atomic mass units. So we take the percentage turned into a decimal times this mass plus the percentage of the other one times its mass, and we do the math and we come up with 35.45 atomic mass units. That's the average mass of a chlorine atom. There's no chlorine atom that actually weighs 35.45 atomic mass units. That's the average, right? It's like there's no person that's normal. That's just some sort of average of all the rest of us, but nobody actually is normal. Notice that the mass of this isotope, 34.97, is very close to the mass number, but it's not exactly the same. There's reasons for that, but we're not going into them. So if you like formulas, I guess you could say this is a formula. This is the overall idea. To find atomic mass, you take the fraction of the first isotope times its mass, plus the fraction of the second isotope times its mass, plus the fraction of the third isotope times its mass, etc. However many you have. So let's do an example. Magnesium has 3 naturally occurring isotopes with masses of 23.99, 24.99, and 25.98 atomic mass units, and natural abundances of 78.99%, 10%, and 11.10%. Calculate the atomic mass of magnesium. So these are listed in order, and the order matches with these. So the 23.99 being first of the masses is going to match with this percentage. So I'm going to take this percentage, 78.99, and I'm going to convert that to a fraction, a decimal. So 0.7899 times the mass of that isotope, 23.99 atomic mass units. And then I'm going to add the next percentage, 0.1000 times its atomic mass, 24.99 atomic mass units. Taking up too much space here. Plus 0.110 times the last one, 25.98 atomic mass units. Everybody okay with that? So on your calculator, just start at the left, 0.7899 times 23.99 plus 0.1 times 24.99 plus 0.111 times 25.98. Enter. So my calculator gives me 24.332481, and the unit would be atomic mass units. Significant figures with this becomes messy, and I don't see the point in torturing you with sig figs in terms of calculating atomic masses. So let's just go for ballpark. The percentages here were each 4 sig figs, and the masses were 4 significant figures. So let's round the average mass to 4 significant figures. That's a reasonable thing to do. So we'll keep the first 4, and we'll say that the average is 24.33 atomic mass units. Any questions? This is not a big deal kind of skill, but I feel like we need to teach this to you because you need to understand where those crazy numbers came from on the periodic table. They are the average masses of all the naturally existing isotopes of those elements. And since we always deal with huge numbers of atoms, it's most useful to have the average atomic mass.